Section 5.5, example 7, using the linear factorization theorem to find the polynomial with the given zeros. So find the fourth degree polynomial with real coefficients that has zeros of -3, 2, I, such that f of -2 is equal to 100. Ooh, this sounds like fun. Okay, so we have a fourth degree polynomial. And what we know for sure is that we have these zeros. So let's start with that first. F of x is equal to, here we have a zero of x equals -3. So to find the zero, so the factorization part, we're going to set it equal to 0. So we have x plus 3 here. And just the opposite over here. So we have x equals 2. So that tells us that the 0 or the factor that was factored out was x minus 2. And here we have something pretty cool. So whenever we have I, we also have its complement. Just a minute. Conjugate. So we have its conjugate as well. So not only do we have I, but we also have -I. So we have x minus I. We also have x plus I. So let's figure this part out first. And then we could see what we could do about this over here. So let's multiply all of this out. Or instead of doing all of that, why don't we actually set it equal to, like, let's evaluate our function at this part. Let's put a random variable over here so that way we could force it to equal 100. So let's shift this over a little bit. We'll say A over here. And now we're going to plug this part in here. So we have f of -2. So everywhere we see a negative, or everywhere we see an x, we're going to plug in a -2. Plus 3, -2 minus 2, -2 minus I, -2 plus I. And this is all going to equal 100. We're going to force it to equal 100 by having this A here. Once we're done, we could expand everything and make it look a lot better than what it looks like right now. But what we have is A, -2 plus 3 is going to be 1. -2 minus 2 is -4. And we have these two parts, -2 minus I, -2 plus I, which should all equal 100. So it looks pretty disgusting right now, but we could expand this. This should clean up really nicely. And at the same time, we can multiply these right here. So we have -4A times -2 times -2, +4, -2 times I, -2I, -I times -2, that's going to be a +2I. -I times I is going to be -I squared. This should all equal 100. -4A. Here, these two subtract out. And we have 4 negative, or I squared becomes -1. -1 times negative is going to be positive, so +1 equals 100. So now we have 5. This part equals 5. 5 times -4 is going to give us -20. And is equal to 100. And to get A by itself, we're going to divide that -20, giving us -5. And everything looks really good right now. So now what we have is f of x is equal to -5 times x plus 3, x minus 2, x minus I, x plus I. And one more thing. So using linear factorization theorem, fourth degree polynomial. So we should have x to the power 4, or at least 4 multiples of x. 1, 2, 3, 4. And it looks like we satisfied everything that they were asking us to do. So finding these zeros, this initial condition, fourth degree polynomial, real coefficients. I think we have everything. So let's expand this because right now we don't have real coefficients. It's not all real. So let's expand it, see what we end up getting. So -5. Let's multiply these two first. That's going to be x squared minus 2x plus 3x minus 6. And let's multiply these two. We have x squared plus xi minus xi minus I squared. So combine like terms here. X squared plus x minus 6. Combine like terms over here. Those two subtract out. I squared is -1 times negative is going to be positive. So what we have here is x squared plus 1. And now we could just expand. So because I'm a little bit lazier, I'm going to expand this way. So x squared times x squared here and here. Still going to keep it in parentheses though, because we have to multiply that -5 at the end. That's going to be x to the power 4 plus x cubed minus 6x squared. And then all of that times 1. So plus x squared plus x minus 6. Combine like terms, x to the power 4, there's only one, plus x cubed, there's only one of those, x squared, we have -6 plus 1, that's going to be -5x squared. X's, we only have one, plus x, -6, we only have one constant. And we're multiplying each of those terms by -5. -5 x to the power 4, -5 x to the power 3, plus 25x squared minus 5x plus 30. And there we go. Now we have absolutely everything that they wanted us to have. One more time, find a fourth degree polynomial with real coefficients. Fourth degree polynomial, we have x to the power 4, perfect. Real coefficients, they're all real. That have zeros of -3, 2, and I. That's literally what we had here, such that f of -2 is 100. We've set a random variable in the very front to give us exactly what we wanted. And there we go. If you have any questions, please feel free to ask. Otherwise, bye.